If we take a square root of a number that's already a perfect square, then you just say the square root of 64 equals what? You just say it equals 8. Hang on. I need a red pen. Hide that. Equals 8, and there you're done. Right? But if we are going to take a square root of something that's not a perfect square, like 24 is not a perfect square, then we have to do something called simplify the radical. Now, we are not going to take decimal answers here, y'all. Okay? If you put a decimal on your paper when we're doing what we're going to do with these special right triangles, I am going to mark it wrong, even if it's mathematically correct. Okay? Because we use simplifying radicals to do our special right triangles. So that's why I'm going through this little review with us. All right. So, square root of 24. It's not on my list of perfect squares, right? There's nothing that multiplies times itself to get 24. So what we have to do is we have to break 24 into a factor that is a perfect square. So you're looking for a number that goes into 24 that is a perfect square. Now, 24 is before you get to 25, right? So if there's a perfect square that goes into 24, then it's going to be one of these three, actually, because this one won't help us, right? Did any of those three numbers go into 24? 4 does, right? So 4 does. What times 4 equals 24? So the square root of 6 times 4. I need to regulate it. I like to put the square in the front. Sorry. Put the perfect square in the front. So the square root of 24 is the same thing as the square root of 4 times 6. What is the square root of 4? 2. Bring that outside. The square root of 4 is 2. So 2 goes to the outside. And then we can't simplify the square root of 6, so you're going to leave it 2 radical 6. Okay, so the square root of 24 reduces to 2 times the square root of 6. Do y'all remember me teaching that to you in Algebra 1? I did it. It was probably after the end of course test, but I did it. And I said, I'm teaching this to you because you're going to need it in geometry. Okay, so here we are in geometry doing Algebra 1. So, square root of 96. Is 96 a perfect square? No, but it falls between 100 and 81, right? So are any of these perfect squares numbers that go into 96 evenly? And I want the largest one that does. So what's the largest perfect square that goes into 96? 9. Well, if it does, 16 is bigger than 9, right? 9 don't go into 96 anyway. 16 times what? 6. So I changed this to the square root of 16 times 6. And what is the square root of 16? 4. So my answer is 4 radical 6. Okay? All right. I don't know what just happened there. All right, here's another one. Square root of 75. What is the largest perfect square that goes into 75? 25. 25 times what equals 75? 3. So I changed that to radical of 25 times 3. And what's the square root of 25? 5. So this is 5 radical 3. So whatever is left over in the radical stays in the radical. Whatever you can take the square root of goes outside. All right. Problem E, square root of 700. What is the largest perfect square, do you think, that goes into 700? 100 is, right? 100 goes into 700. 100 times what? So square root of 100 times 7. And what's the square root of 100? 10. So this simplifies to 10 radical 7. Y'all getting the hang? Okay. 72 is a fun one because there's actually lots of perfect squares that goes into 72. 4 goes into 72, right? But to make it more simple, you need to pick the largest number that goes into 72. What's the largest number that goes into 72? It's 36. Very good. So it's 36 times 2. And what's the square root of 36? So this reduces to 6 radical 2. Now let's just say that I didn't pick the largest perfect square that goes into 72. What if I just said, well, 72 is 9 times 8? That's true, isn't it? Right? So what if I did 9 times 8 instead of 36 times 2? Well, what's the square root of 9? 3. So that would be 3 radical 8. But 8 also has a perfect square that goes into it, right? What's the largest perfect square that goes into 8? 4. So I would change that to 3 radical 4 times 2. And what's the square root of 4? 2. If you already got a 3 on the outside, you would multiply it when you bring it out. So 2 times 3 is 6. So if you accidentally don't use the largest perfect square at the front end, if you notice what's in the radical still has a perfect square that goes into it, you can keep breaking it up. Does that make sense? Because we eventually got to 6 radical 2 again. So any questions about that? But yeah, always try to use the largest perfect square. Fractions. All right, if you take the square root of an entire fraction, then you need to take the square root of the whole fraction. That means you take the square root of the numerator and the square root of the denominator. Okay, so the square root of a fraction, you need to take the square root of the numerator and of the denominator. All right, so we have 1. And then what's the square root of 25? Over, what's the square root of 49? And then if the fraction can be simplified, you do that. But 5 over 7 is already reduced. Okay with that? So if it's a fraction, you do it the numerator and the denominator separately. Okay. This is where radicals get complicated. Now, there is a rule about radicals. And you want to write this down. I'm going to write it down and try to highlight it. You cannot leave a radical, that's an ugly radical, in a denominator. If you leave a radical in a denominator, it is not simplified. You cannot leave a radical in a denominator. So you can leave one in a numerator, but not in a denominator. Okay, so the problem H right here, the 5 and the 2 each already have their own radical. Does radical 5 simplify? Are there any perfect squares besides one that go into 5? No, because it's a prime number. Same with radical 2, right? So there's no perfect squares besides ones that go into those numbers. But we cannot leave this radical 2 in the denominator. So to fix that problem, we do something called rationalize the denominator. We rationalize the denominator. Now to rationalize the denominator, that means you take that denominator, which is radical 2 this time, and you multiply by that denominator over itself. So multiply your fraction by radical 2 over radical 2. Now, what does anything divided by itself equal? 1. So I'm really not mathematically changing the value of this fraction if I'm multiplying it times 1. I'm just going to change the way it looks. Okay? I'm just changing the way it's presented to us because we cannot leave a radical in the denominator and be simplified or mathematically correct. Okay? So we multiply fractions across. Radical 5 times radical 2 equals radical 10. And then radical 2 times radical 2 is radical what? 4. You multiply the insides of the radicals together. Now, does radical 10 simplify? Are there any perfect squares besides one that go into 10? No. So you leave radical 10 alone. And what's the square root of 4? 2. So what you do is you make the denominator basically a perfect square. So when you take the square root of it, it's just a whole number. Does that make sense? So this is the simplified answer. Now you cannot simplify the 10 and the 2 because this one's under a radical. You cannot simplify something that's inside a radical with something else. All right. So that is my final answer, radical 10 over 2. Okay. That is called rationalizing the denominator. Rationalizing a denominator. So we're going to practice that another time, or 2, or 50. I don't know. Whatever y'all need. All right, so I have 12 divided by radical 5. Now, this is the only part that has the radical, is the denominator, right? Are there any perfect squares that go in that denominator? No, there's no perfect squares that go into 5. So I'm going to rationalize the denominator, which means I do what? Right, you multiply by a fraction of that denominator over itself. So radical 5 over radical 5. Now we multiply fractions straight across, but look here. Do you notice how the 12 is outside of a radical and the radical 5 is inside a radical? So that's just kind of like multiplying 12 times x. You just put them together, okay? If you have one outside and one inside, you just squish them together like it's a variable. So 12 radical 5. And on the bottom, since they're both inside, you can multiply them together. What's radical 5 times radical 5? Radical 25. And again, we cannot simplify radical 5, so we're going to leave 12 radical 5 alone on top. Over, what's the square root of 25? 5. And then since these are both outside, you see if you can reduce 12 over 5. Will that fraction reduce? No. No, it's improper, and it's okay that it's improper, but 12 over 5 doesn't have anything that goes into both of them except for 1. You cannot simplify the 5 because this one's under a radical. So that is my simplified answer. Okay? Cannot leave radicals in denominators. Numerators are okay. Let's do this one. This is the last one I got. Now, why do you think I'm doing some just practice problems on rationalizing denominators? Because we're going to need to use them on triangles in just a minute. Okay? We're going to use them with triangles in just a minute. So, radical 12 over radical 2. Now, radical 12 will simplify as a radical, but since I'm going to have to rationalize the denominator anyway, I'm going to wait and simplify that in a minute, okay? Because I'm going to have to simplify extra after I multiply probably, so I'm just going to go ahead and multiply by radical 2 over radical 2. Denominator over itself. So go across. What's radical 12 times radical 2? Radical 24. And what's radical 2 times radical 2? Radical 4. Now, does that 24, is there a perfect square that goes into that? 4 times what? Sorry, I jumped ahead. Radical 4 times 6. And what's the square root of 4? So that top is 2 radical 6. Y'all with me? And what's the square root of 4? 2. Just plain 2, right? Y'all see something we can simplify? 2 divided by 2 makes what? 1. So the answer is just 1 radical 6 or just radical 6. You cannot. You're not supposed to divide with radicals. You can multiply with radicals, but you cannot divide. You're supposed to simplify. But it would make sense, but you can't do it. It's mathematically incorrect. All right. Get out your notes packet. We are on page 4, I believe. Is that correct? All right. This is page 4 in our notes packet. get my page. 32 notes. Now, we have two kinds of special right triangles. The first one we're going to talk about is a 45 degree, 90-degree right triangle. Okay? So that's when we have one right triangle, obviously, since it's a right triangle, and the two other angles are both 45 degrees. Okay? So let me draw one on the board over here, just this example right here. The right triangle, 45, 45, 90. Got a right triangle, this way. Right angle, both angles are 45 degrees. Okay, so this is actually also an isosceles triangle. Okay, both of these legs are going to be the same amount, and we call those legs X. And the hypotenuse we're going to call X radical 2. So the legs are just a number. And to get the hypotenuse, we're going to multiply the length of the legs times the square root of 2. So you need to memorize this about 45, 45, 90 triangles. We're going to have a quiz probably Wednesday of next week on special right triangles, Pythagorean theorem, and then similar right triangles that we're going to learn next week. Okay? Now, see where it's highlighted? And I told you that the legs are going to always be congruent. The angles are congruent, so their opposite legs are congruent. Okay? So look at number 1. Y'all are going to think this is simple. It is. So this 8 right here that they gave me, this is a 45, 45, 90 triangle, even though they only gave me one angle, right? Because I know if I subtract that from 90, this one would have to be 45, wouldn't it? Okay? So this is a 45, 45, 90 right triangle. This 8 that they gave me, is that a leg or is that a hypotenuse? It's a leg. What letter variable represents the other leg? X. So if that leg is 8, what is the other leg going to be? 8. So X is 8. All right. So what did it say to get the hypotenuse? You take the leg and you multiply it by what? Radical 2. Guess what 8 times radical 2 is, y'all? 8 radical 2. And you're done. Okay? That's it. If the whole number is a leg, if the leg is a whole number, that's all you do. Okay? So the simplifying will come in if the leg is not a whole number. If it's got a radical. Sometimes it will. All right, number 2. So again, this is a 45, 45, 90 triangle. We have an X and a Y. This 25 they gave me, is that a leg or a hypotenuse? It's a leg. So which other variable is also a leg? Y is a leg. So what's the value of Y going to be? 25 as well. Oops. And X then is the hypotenuse. So how do I get the hypotenuse if I know a leg? Multiply by radical 2. So that's going to be 25 radical 2. 25 radical 2. That's it. Y'all with me? So number 3. This was a little bit more complicated. Because that 19 that they gave me on this 45, 45, 90 triangle, is that a leg or a hypotenuse? All right, this time they gave me the hypotenuse. So think about it. When they give me the leg, I multiply by radical 2 to get the hypotenuse. So what do you think I do to get a leg if they give me the hypotenuse to start with? What's the opposite of multiplying by radical 2? Dividing by radical 2. Y'all see that? Since they gave me the hypotenuse to get the legs, I have to divide by radical 2. So it's going to be 19 divided by radical 2. Now we're going to have to come into play and do what we just did with rationalizing the denominator. Y'all see how this is going to come out like that? Because if you divide by a radical, you can't leave radicals in denominators, so you have to rationalize it. So that means we multiply across by radical 2 over radical 2. What's 19 times radical 2? 19 radical 2. Squish it together like it's a variable. Over what's radical 2 times radical 2? And what's the square root of 4? So that's going to be 19 radical 2 over 2. Does 19 over 2 reduce? Nope, 2 don't go into 19. So both of my legs are 19 radical 2 over 2. 19 radical 2 over 2. 19 radical 2 over 2. Because both legs will be the same measure. So if they give you the hypotenuse, you divide by radical 2. If they give you the legs, you multiply by radical 2. You'll see the difference there? Okay. I'm going to go ahead and do 30, 60, 90s. Okay? So they're slightly more complicated sometimes. Not always. Now, we're going to spend another day on this on Monday. We're going to do extra practice on this. So if this lesson seems long, that's okay. We're going to have time to practice some more on Monday. Okay? And that'll give our time for people that need to make up the benchmark time to do that. Okay? So, 30, 60, 90. So that's when you have a 90-degree angle, a 30-degree angle, and a 60-degree angle. And you got to memorize these special triangle lengths, okay? Now, what they have highlighted, or what I've highlighted over there, is very important. The shortest leg is always across, or opposite. Opposite means across from it, not touching, the 30-degree angle. And the longer leg is always opposite the 60-degree angle. So you got two legs. The short leg is across from the 30. The long leg is across from the 60. What do they have? They have the 30 on top. So I'll draw my 30 on top. So this is 30 degrees. So that means this down here is my short leg, right? And that's going to be X. That means this leg over here is my long leg, and it's going to be the short leg times radical 3. And the hypotenuse is going to be double the short leg. So we call the short leg X, the long leg X radical 3. X times radical 3. And the hypotenuse is 2 times X. You can't really see my radical. So if you know the short leg, it's great. Okay? It's always easiest to me if you know the short leg. Okay? So memorize that. Short leg is X. That's across from the 30. The long leg across from the 60 is X radical 3, and the hypotenuse is 2 times the short leg. Okay? So, look at number 4. So they gave me that this angle is the 60-degree angle, so that means this angle up here is the what? 30-degree angle. So this 5 that they gave me, is it the short leg, long leg, or the hypotenuse? It's the short leg. They gave me the short leg, which makes it the easiest to me. Okay? So to get the long leg, I take the short leg and multiply by what? Radical 3. So this is going to be 5 radical 3 for X. And to get the hypotenuse, you do 2 times X, or 2 times the short leg, right? So what's 2 times 5? 10. Okay, so to me, these are always the easiest if they give you the short leg. So they give you the short leg, you multiply to get the long leg, you multiply the short leg by radical 3. And if you need the hypotenuse, you double the short leg. All right. Number 5 here is a 30, 60, 90 right triangle. So that 14 that they gave me, is that the short leg, the long leg, or the hypotenuse? Short leg. Now what's the long leg? X or Y? Y is the long leg, because this is a 60-degree angle up there. You need to label that. So how do I get Y?
14 radical 3.
Yeah, it's 14 times radical 3. So that's Y. So make sure when you put it in the blank, you put it for the right variable. And then X is my what of that triangle? Hypotenuse. Sorry, I completely come out of my shoe, y'all. And so I double the short leg, right? And the short leg was what? What is 14 times 2? 28. There you go. Pretty cool. Now, number 6. Slightly more complicated, right? Like, seriously, I slipped my foot out here. So, on number 6, that 32, that side with the length of 32, is that a short leg, a long leg, or a hypotenuse? It's a hypotenuse. Now, I told you, life is easier to me if you can get the short leg. So, if they gave us the hypotenuse, how do we get the short leg? That's it. You just take half of it, right? So, what's 32 divided by 2? So, this X over here is the short leg because it's across from the 30-degree angle. So, that one's 16, right? Okay with that? So, how do I get the long leg? And it's just going to be 16 radical 3, right? Any questions? Any questions? Now, y'all, if y'all tell me decimals on these, I'm going to mark them wrong. I will. Totally. You don't see decimals on my paper, I better not see any on yours. So, guess what? They can get a little bit more. Y'all try number 7. It's just like the one we just did, pretty much. Y'all try number 7. Not too difficult, is it? If you can get the short leg, it's pretty easy. I got it? Think you got it? All right, so that 46 that they gave you right there, that length 46, what is that, a short leg, long leg, or hypotenuse? Hypotenuse. So how do you get the short leg if they give you the hypotenuse? Divide by 2. And which one is the short leg, X or Y? Y, because it's across from the 30. So what is half of 46? 23. And so how do you get the long leg if you know the short leg? Multiply by radical 3, so 23 radical 3. So raise your hand if you got 23 for X and 23 radical 3 for Y. Are there any questions? Did I mix it up? Oh, goodness. Raise your hand if you got 23 radical 3 for X and 23 for Y. Okay, good job. Good job, Miss Isabel. Way to pay attention. Okay. Lord have mercy. Okay, so number 8, they're going to give us something we haven't been given yet, and that's the long leg, right? It's across from the 60-degree angle. So they give us the long leg. Well, I can't get the hypotenuse until I get the short leg, right? So to get from short leg to long leg, we multiply by radical 3, right? So how do you think we go backwards? Divide by radical 3. Does that make sense? If they give us the short leg to get the long leg, we multiply by radical 3. So since they give us the long leg to go back to the short leg, we divide by radical 3. Does that make sense? So take a little work for us. So I'm going to say 20 divided by radical 3. So we're going to need to rationalize that denominator, right? So I multiply by radical 3 over radical 3, which is 20 radical 3 over radical 9. And what's the square root of 9? So that's going to simplify to 20 radical 3 over 3. So that goes for y, right? That's the short leg. 20. Oh, I didn't write that too big. 20 radical 3 over 3. Now, if you know the short leg, how do you get the long leg? You double it, right? Well, all you have to do basically is double the numerator number. Okay? So what's 20 times 2? 40. Because that's if I multiply this fraction by 2 over 1, I would multiply the 2 times the 20. Y'all see that? So I'm just kind of saving a step. So the hypotenuse will be 40 radical 3 over 3. To me, that's as hard as it gets. To me, that's as hard as I can get. Does that make sense? So after you get the short leg, which is y in this case, you double it to get the hypotenuse. Yeah, to me, that's the hardest, is when you have to rationalize the denominator going from the long leg to the short leg. Okay. All right, number 9. They gave me one length is 9 radical 3. Sorry, y'all. 9 radical 3. Is that the short leg or the long leg? That's the long leg. So to me, this one's easier. Which one is the short leg, x or y? X. So if I want to get x, which is the short leg, and they gave me the long leg, what do? We'll go from short to long. I multiply by radical 3, right? So, yeah, so to go long to short, I divide by radical 3, which is going to be gravy right here, y'all. Watch. 9 radical 3 divided by radical 3. Well, what's anything divided by itself? So that equals what? 9. So x is just 9. So how do I get the hypotenuse? Double it and you get 18. So the x is 9, the y is 18. That makes sense? Makes sense? All right, that is actually all of notes for today on special right triangles. We will practice some more on those the next time we meet. Have a good day.